learn how to solve inequalities, and what you're going to learn is that there are solution sets that are numbers greater than or less than, greater than or equal to, or less than or equal to a certain number. What you're also going to realize is that you're going to have to draw number lines. You're going to have to create open circles and closed circles and shade to the left and shade to the right. That'll all become way clearer to you once you watch the video. But I do want to make sure that you understand is the very last examples about flipping the symbol. It is imperative that you watch to the end of the video. It is imperative that you copy down all of the solutions for each of the examples. Because the hardest part of this entire solving inequalities, is knowing when to flip the symbol and knowing why you have to flip the symbol. Please watch to the end of the video. Please copy down all of your examples, and if you have any questions, please make sure to ask them. So here are the 4 new symbols that we're going to be introduced to in this video. These are inequality symbols. So when you're used to solving equations where you usually got x equal to one number, then we moved into understanding of infinite possibilities for equations and no possibilities for equations. And now we're going to look at these symbols, and these symbols define a set of numbers that make an inequality true. So x is going to be greater than a number or less than a number, or greater than or equal to a number or less than or equal to a number. So if we looked at these two symbols and these two symbols, the difference between the greater than and the greater than or equal to is that in the greater than or equal to, part of the solution could be the number that you solve for. So if x is greater than 6, it means that all numbers that are greater than 6 will make your inequality true. So 7, 8, 9, 10, 11, 6.5, 6.2, but not 6. If you have x is greater than or equal to 6, it means now 6 is included as part of your solution. So 6 will make the inequality true. Same thing with less than. If x is less than 6, it means 6 is not part of the inequality solution, but 5.99 is, and 5.5 is. If x is less than or equal to 6, it means now 6 is part of your solution. So let's look at how this works. So this is an inequality. 3 times a number plus 9 is greater than 18. And you can think about it as if it was an equation. The difference is you're not just going to get one x. You're going to get a whole bunch of x's, a solution set of x's that you could plug in for x and make the inequality true. You're going to solve it just like it was an equation. So you're going to create 0 pairs. You're going to go ahead and do inverse operations. And in this case, you end up getting x is greater than 3. What that means to you is any number greater than 3 can be plugged back into the original inequality to make it work. So let's pick 4. 3 times 4 is 12, and 12 plus 9 is 21. 21 is greater than 18. Great. If we pick something that wasn't x is greater than 3, so let's say 2, 3 times 2 is 6, and 6 plus 9 is 15. 15 isn't greater than 18. Well, that should make sense because we're saying only numbers greater than 3 would be true. So the solution would be x is greater than 3. And if you were to ask to graph it, which most of the time you're going to be, you're going to take whatever value you get. You're going to make it the center of your number line. And if the symbol does not have a line underneath it, so if it's a greater than symbol or a less than symbol, you're going to create an open circle. And then you're going to ask yourself which side of the number line is greater than 3. Well, 4, 5, 6, infinity, etc. So part of your solution is x is greater than 3. The graph of your solution is the number line where you have an open circle on the number and you shade to the right in this case because you want all numbers greater than 3. Second, 4 times a number minus 16 is greater than or equal to 24. So now we're noticing that when we go as part of the solution, we're going to get whatever the value of x is going to also be part of our solution. So I'm going to add 16 to both sides, and I get 4x is greater than 40. I divide by 4, and I'm left with x is greater than 10. So in this case, x is greater than or equal to 10. I have to carry down the same symbol. In this case, that means that all numbers that are greater than 10, as well as 10 itself, will make this true. So if I plug 10 in, 4 times 10 is 40, and 40 minus 16 is 24. 24 is not greater than 24, but it's equal to 24, so that works. If I picked something that wasn't greater than or equal to 10, like 9, 4 times 9 is 36, and 36 minus 16 is 20, and that's not going to work. So if I were to graph, I'd put 10 in the middle, I'd do 11 and 12, 9 and 8, and I'd say, okay, in this case, because there's a line underneath my symbol, because it's greater than or equal to, instead of doing an open circle, I have to do a closed circle, which looks really messy on this video, but closed circle on 10, and because, again, it's greater than 10, you're still going to shade to the right, because 11 and 12 would make this inequality true. Here are just different symbols. So again, I would simplify it or solve it just as if I would solve any equation. And I get to a place where 5x is less than negative 10. I divide by 5, and I get x is less than negative 2. I create a number line with negative 2, negative 1, 0, 2 numbers to the right, 2 numbers to the left. It's an open circle because there's no line underneath the symbol. It's just less than, it's not less than or equal to. And now in this case, I'm shading left. And the reason I'm shading left is because I want all numbers, I want to shade all numbers that are less than negative 2. So here, I'm going to minus 4, divide by 8, thinking ahead, and x is greater than or less than or equal to negative 2. So I have x is less than or equal to negative 2. So now I have that line underneath, which means part of my solution could also be negative 2. Again, I make that same number line. And in this case, now I say, okay, it's not an open circle anymore. It's a closed circle because I have that equal sign. So the equal sign underneath my symbol, that line. So I close circle it. Again, I ask myself, which way am I shading? Well, I'm shading left again because it's all numbers less than negative 2. So here are the tricky ones. And the tricky ones are tricky because when the coefficient of the variable that's left at the very last step is negative, so you are either dividing or multiplying by a negative number that's the coefficient of x at the very last step, you must flip the symbol. So you're going to proceed with this just like you would go through any other of the problems that we have done. You are going to get to a place where the very last step to isolate your variable is to multiply or to divide by the negative 3. So in this case, you're going to continue to simplify, continue to solve, and you're going to get x and negative 3. Because the coefficient of x was negative, in this case, you must flip the symbol. So what was originally a less than sign now becomes a greater than sign. So when you go through and you make your number line, you are going to now be shading to the right because you want all numbers that are greater than negative 3. You're going to create an open circle. And what I haven't made clear yet is that the reason it's open is because shading represents solutions. So if it's an open circle, it means the number that the circle is open on is not part of your solution. But everything that you shade is part of your solution. So because negative 3 is not part of your solution, if you plug negative 3 back into your inequality, negative 3 times negative 3 is 9, and 9 plus 6 is 15. 15 is not less than 12. Negative 3 is not part of your solution, but every number greater than negative 3 will be part of your solution. That's why the circle is open. The reason you flip your symbol is because inequalities do not account for the rule that negative times negative is positive. And because it doesn't account for this rule, we have to, as mathematicians, flip the symbol in order to help the solution out. We have to make sure that we are creating solution sets that will make the inequality true. So for the last one, you're going to go ahead and do the same thing by subtracting 4, just like you would do in any of the other ones that we have done so far. And you get to a place where you're completing the very last step. So you have x and you have positive 10. Your original symbol was greater than or equal to, so now it becomes less than or equal to. And when you create your number line, 10 is the center, and you go up 2 and down 2. And in this case, it's a closed circle because you need your 10 to be shaded because 10 is part of your solution. And you're going to shade to the left because we want all numbers that are less than or equal to 10. So 9 and 8 have to be shaded because shading represents solutions.